Good day everyone. Today we are going to present about the program-based learning for the subject microcontroller technology. I am ANBARASU SHANMUGAM B0119109196 together with AMINUDDIN HAZIQ bin Ahmad AFFANDY and KATHIRESSAN Magindran will present you the auto closing barrier, which the topic we choose to do the program-based learning. Our supervisor is Prof.Mad.Dr. Ahmad Zaki, and we are from section 2. Let's move on to the introduction. For introduction, nowadays security is extremely vital since many security systems have been created, including the usage of security guards, alarms and monitoring systems, as well as the creation of electronic hardware, software and other items. One of the most critical safety systems is about to shut down. So here we will see the warehouse which is located in each company. So they need a security guard. Besides that, the security guard, when the security guard is not functioning, the warehouse is not watched out. So the warehouse must be watched at all times to prevent theft. The prevalence of crime, particularly robbery, has increased in recent days, which has concerned with the firm owner. As a result, the auto-closing barrier in the company must be upgraded in order to reduce the crime rate. We will move on to the introduction, where we will see the problem statement. Despite the availability of a security guard and the installation of a security lock, the burglar was able to breach in and steal their goods. Second problem statement, workers' carelessness in failing to securely lock the warehouse door may make it much easier for a burglar to steal the supplies. The objective of the program, to design a low-cost security system where it can be afforded by low-budget company. Next, to overcome the human mistake by leaving the barrier open. Third one, to make a high security by adding the security password. Okay, our project scope is focused on leveraging the microcontroller knowledge learned in class to write software to operate a smart security system. The system has keypad for PIC to recognize the password and LCD to display the password to unlock the barrier.
Hi, my name is AMINUDDIN bin AFFANDY. For my part, I will explain Phila's table for my group project. First, fact number 1, employee forget to close barrier. Idea, the barrier close automatically at set time. Learning issue, warehouse barrier will automatically be closed and secure. Action, use microcontroller to control the barrier. Solution, using timer countdown to close the barrier. Second, fact number 2, safety from invader and burglars. Idea, require password. Learning issue, warehouse will be secure from robbery. Action, microcontroller will check the password inputted at the keypad. Solution, using LCD, keypad and if-else coding for the password. Thirdly, fact number 3, test distribution. Idea, to complete the design according to the plan. Learning issue, learn to work together with group member. Action, identify suitable tasks for group member. Solution, team leader distribute the suitable tasks for each group member. Lastly, fact number 4, simulation using Proteus, 8 professional and write program coding with MicroC Pro. Idea, identify the input and output device of MicroC to be used for auto-closing barrier. Learning issue, learn how to write program coding using MicroC and simulate in the Proteus. Action, make the coding in the MicroC and draw the circuit in Proteus for auto-closing barrier. Solution, refer to coding and simulation example in the internet, also group discussion. Next part, I will explain the flow chart of this group project. At the start of the flow chart, The LCD will display Welcome Master for 1 second and then change to Insert Password with empty space for the password. By using the keypad, the user can key in the password. If the password is not matched, the LCD will display incorrect password. Try again and return back to insert password display. Also, the red LED will turn on for short time indicate that the password is not matched. If the password is matched, the LCD will display password match and the green LED will turn on for short time. And then the DC motor will turn on in clockwise for a period of time to open the barrier. After the barrier open, the LCD will display press hashtag to off and lock again, and the timer for closing the barrier will start from period of time. If the time limit is reached to 0 or button hashtag is pressed before the time limit, the motor will close. The motor will turn on anti-clockwise for a period of time to indicate closing the barrier. After the barrier closed, the LCD will display insert password again.
Okay, let's move on to the coding part. For the coding portion, we use Micro C Pro and we use the microcontroller PIC16F877A. Firstly, we set the processor clock frequency up to 20 MHz. And here we can see the Micro C coding examples. Move on to the schematic capture. We design our schematic capture using Proteus 8 Professional. The components we are used are PIC16F877A microcontroller, two DC motors, L293D motor driver, two red LEDs, two green LEDs, a keypad phone, a LCD LM016L, resistors, and an oscilloscope. So let's move on to the coding section. For coding section, first we unsign the short keypad system and then we set the actual password, and the password is 170598, and we initialize the count. For the LCD module connection, we S-bit the LCD RS pin to RB 4-bit, LCD EN pin to RB 5-bit, LCD D4 pin to RB 0-bit, LCD D5 pin to RB 1-bit, LCD D6 pin to RB 2-bit, and LCD D7 pin to RB 3-bit. And then for LCD RS direction, we connect with the TRISB 4-bit, LCD EN direction to TRISB 5-bit, LCD D4 direction to TRISB 0-bit, LCD D5 direction to TRISB 1-bit, LCD D6 direction to TRISB 2-bit, and finally LCD D7 direction to TRISB 3-bit. Here we end LCD module connection. Next, we initialize the keypad module connection, where the keypad is connected to the port D, and we end the keypad module connection here. Move on to the void password prompt. Password prompt, which indicates the password is accept or reject. We clear the LCD display. Once we clear the LCD display, the display will show insert password in first row and the LCD blink cursor will on. The initialization start here. We void initialization. For LCD initialization, the LCD will clear the display and the cursor is off. And then once we run the program, the Micro C project text will appear on the display for 1 second, and then it will show welcome master for 1 second. Next, it moves to the password prompt, as it will wait for the password to key in and it will analyze the password to accept or reject. We set the port B as output with 0 voltage, and then we set count is equal to 0, and we initialize the keypad. The initialization ends here. For the password check routine, we start the initialization check password. Firstly, the password is given and the password is consists of 6 digits. If the password we key in is accept, it will show the password is matched for 2 seconds. After that, the system will shows it will unlock for 2 seconds. At the same time, we set port B.F6 is equal to 1, which it will active high and the green LED will turn on, which indicates the password the key in is correct. And it will turn on up to 2 seconds and it will turn off. The loop will return or else if we key in the wrong password, it will show incorrect password and it shows try again for 2 seconds. At the same time, port B.F7 will active high, which indicates the red LED will turn on and it shows the password we key in is wrong, and it will turn on up to 2 seconds. After that, it will turn off. And here the password prompt where it will return to here for this section to insert the password, and the loop is continued. And the password check routine ends here. For this part, we use timer 0 and we unsign the count, we void interrupt and the count infinity, and we set timer 0 is equal to 96. And int count is 0 times 20, where it will clear the flag by the software, where 0 times 20 is indicates in binary 000100000. Move on to the main, void main. The option register is set to 0B10000000, where the bit 7 is active high. And for incon, we set bit 7 is active high, bit 6 is active low, and bit 5 is active high, which to allow or disallow the interrupts. We set the bit 7 to high to enable the unmasked interrupts, and we set the bit 6 is 0 to disable the unmasked pre-held interrupts. And lastly, we set the bit 5 high to enable the timer 0 interrupt. We set port C as output with 0 voltage, and we define the coding as try C is equal to 0 and port C is equal to 0. And we set the timer 0 is equal to 96. And we initialize the count. And here the action. We set the system to turn on by clicking star button. We set the star button is 13. Once we click the star button, it will turn on the LCD and the dialog box will appear on the display. And if key in the 6-digit password, the check routine will continue here. And according to the password check, and it drives the motor. If the password is correct, we set the port CF.0 is equal to 0 and port C.F1 is equal to 1, which indicates the H-bridge concept system. Once the password is checked and the password is matched, the motor will turn on, and we define the upper motor rotates anti-clockwise and lower motor rotates clockwise, where the two gates are opening with full speed. At the same time, we set the connection with the LED green LED, where the LED will turn on as the motor is turned on, which indicates the gates are opening. After 5 seconds, the port C is become to 0, where the motor and the LED green will turn off. Once done, the LCD will display press hashtag to off the system and lock the gates again. So we set the hashtag pin is 15. Once we click the hashtag, the LCD will turn off. But after showing this dialog, the LCD will turn off, and after 2 seconds, we set the port C F0 is equal to 1 and port C F1 is equal to 0. We can see the difference. F0 is equal to 1 and F1 is equal to 0. Here we set 0 is equal to 0, F1 is equal to 1. It means here the motor is on and the upper motor will rotate clockwise and the lower motor will rotate anti-clockwise in different direction, and the gate are closing with full speed. At the same time, there is a red LED connection between the motors, which shows the gate is closing. After 1 second, the port C is equal to 0, which means the motor is off and the red LED is off, the system is off. To on again the system, we have to wait for the timer because we set the timer up to 96. And here we define the keypad instruction. As shown before, the 13 means the star and 15 means hashtag. We can uncomment this block for keypad 4x4. And here the timer coding. If the count is equal to 1, the port C is equal to negative port C and the count is equal to 0. So we build the coding, and before that, we check in all the libraries for no error, and then we build the coding. Once it built, we go to the we go to the Proteus 8, and here's our connection. PIC 16F877A microcontroller, red LED resistor, green LED resistor, LCD connections, and keypad connection to port D, and then port C connect to the motor driver, where the LED green and red LED is connected between the connection of motors, motor 1 and motor 2. So we set the program file, and as we said, the processor clock frequency we set to 20 megahertz, and okay, and then we run the simulation. Okay. For the LCD turn on, we click on star button, MicroC project, welcome master, insert password. So firstly, we insert the wrong password, 1 digit, 2 digit, 3, 4, 5, 6. Incorrect password, try again, and the red LED is turned on. And then it back to the insert password and the red LED is turned off. Now we enter the password 1705 9, 8. Password match. Unlocked. LED green is turned on. Here the LED green is turned on, and the motor 1 is rotates and motor 2 is rotates, and we can see the graph. Okay, once it rotate enough, once the gate is open, it shows press hashtag to off and lock again the system. So once the gate is opened, and it will show this to lock the system. So we press the hashtag and then it will turn off. A red LED is turned on and the motor is rotate, which indicates the gate is closing. Once the gate is closed, the red LED is turned off. To turn on the system again, we click the star button, but it will not turn on because of the timer we set to 96. So for that, we create a short. We set 1, 5, 1, 3, star 3. And the system is turned on again. We create this for the shortcut. In a nutshell, the automated lock system detects where the barrier is open or closed and then displays the result on the LCD. We are all aware that warehouse safety and security are critical. This technique may use to construct a low-cost security system that a low-budget firm can afford it. Then, to overcome the human error of accidentally leaving the barrier open, it also intended to increase the security by including a security password, which no one will able to open the barrier system without knowing the correct actual password. All of the project objectives have been met and the project is success. Thank you.